So we're going to solve the your turn question for example number 3 on page 319 of the pre-calculus textbook. We've got cos 2x is equal to cos x, and we're going to solve this for the domain. Actually, we're going to solve this using a general solution. And that's where x is all real numbers. We cannot solve any double angle without replacing it with using the trig identities. And so I'm going to choose for the cos 2x, the cos double angle, I'm going to choose to replace it with 2 cos squared x minus 1 is equal to cos x. And I've made that choice because I can see that this will turn into a quadratic equation. I bring the cos x over, so I do that. I subtract cos x from both sides. So I have 2 cos x squared minus cos x minus 1 is equal to 0. And now we need to factor this quadratic. We're looking for two numbers. Those two numbers must multiply to -1, and they must add to multiply to -2 and add to -1. And clearly that's -2 and +1. So we split this term into -2 cos x and plus cos x. Complete the -1 equals 0 and bring down the 2 cos squared x. Group our two factors. We have 2 cos x as a common factor. That leaves us with cos x minus 1 plus, and a common factor here of 1 only, and we're left with cos x minus 1, and all of this equals 0. Complete our factoring with 2 cos x plus 1 times cos x minus 1 is equal to 0. Now we set each one of our terms equal to, our factors equal to 0, so we have 2 cos x plus 1 is equal to 0, and cos x minus 1 is equal to 0. Solve for cos x. We have cos x is equal to -1/2, and again solve for cos x, and cos x is equal to 1. So if we stay within that first cycle from 0 to 2 pi, we can recognize that cos x is equal to -1/2, and cos is negative in quadrant 2 and quadrant 3. And so x is going to equal to 2 pi over 3, and in that first cycle it will also equal to 4 pi over 3. And the only place where we have cos of x equaling 1, remember this is a positive 1, and so the only place for that is at 0, and then again at 2 pi. So if we think about our unit circle for 2 pi over 3 and 4 pi over 3, we can see that there isn't a 90 degrees and we don't continue to add 90 degrees to it. We're going to have to write these two separately. So we're going to, for our general solution. So we have 2 pi over 3 plus 2n pi. Right? So we can have, imagine ourselves, we could do, if n was 0, that gives us 2 pi over 3. If n is 1, we have 2 pi over 3 plus 2 pi going all the way around like that. And then for the 4 pi over 3, it works exactly the same way. We have 4 pi over 3 plus 2n pi. Now we come here, and with this we recognize, oh, that's exactly 2 pi, and each of my cycles it will be 2 pi. So if we go 2 pi n, or 2n pi, either works, and we identify this as our n as an integer. We also identify that x is all real numbers. And that is the solution, the general solution for cos 2x is equal to cos x.